Good morning. This is your Stat Sensei, Mr. Spensei, and this is a review video. This is going to be fairly long, and it's going to be in two parts. And I think this will be probably your best tool for reviewing for the FRQ test. The FRQ test will be basically a single scenario, and it will have 9 questions associated with it. You're going to need to work rapidly to finish those 9 questions, but you should be able to do so fairly easily if you have practiced, and that's going to be really important. So hopefully this will be very useful to you. I'm going to work as rapidly as I possibly can through this, but you may need to put it in on faster speed just because it's going to take me a while to work through some of these problems. All right, so let's begin. And by the way, this is all based on a 2019 question number 5, although we've expanded it and added a lot to it. So a company that manufactures a smartphone developed a new battery that has a longer lifespan than that of a traditional battery. From the date of the purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal. And by the way, that's a great phrase to tell us. That means the underlying distribution is normal, which means regardless of the sample size, when we talk about the distribution of the means, the distribution of the means will have the shape of a normal. So the mean with mean of 30 months and a standard deviation of 8 months. Yay for normality. For the price of $50, the company offers a 2-year warranty on the new battery for customers who purchase a smartphone. The warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works within 24 months. All right, so we have a warranty. The warranty costs $50, and they will replace the battery for free if it goes without in 24 months. They tell me the shape is normal with a mean of 30 and a standard deviation of 8 months. Great. So what is the probability that a randomly selected battery from the company lasts between 25 and 31 months? All right, so I'm going through this exactly the way we would point this out, or the way you get points on it. So we're going to start off with the probability statement. And we want the probability that X will last between 25 and 31 months. So the probability statement is going to be 25 less than or equal to X, less than or equal to 31. If you want to just do probability less than statements, that's fine as well. So there's my probability statement. The next thing I'm going to need is some sort of graph. In this case, because we're working with a normal, we'll have a normal graph. And in this particular case, we know that the mean was 30 months. And this says 25 to 31. Well, I'm going to say 31 is about here. And this is 25 somewhere down here. All right. You can put your labels down below. I just usually am unable to because my writing is not very good. Please remember for shortness, this goes to negative infinity. This goes to positive infinity, but not necessary to have that label. All right. So we need to have that. So we need to have the probability statement. We need to have this. Now, in this case, we're going to convert these to z-scores or a z-score equation. So my probability for my z-score, and we're going to, since we have 2, we're going to take the highest one minus the lowest one. So the probability that z is less than or equal to 31 minus 30 over our standard deviation of 8, because we know that our mean was 30 or standard deviation of 8, minus the probability that z is less than or equal to 25 minus 30 over 8. All right, so we have 2 probability statements associated with the z-scores, and it's very important that you actually show your z-scores. Now, you can work with this in 2 different ways. I'm going to grab this calculator because I think it's the lighting setup's better on. Yeah, the lighting setup is pretty good on this. So stat test. I went to stat test. I went to z-test. I set my mean at 30, my standard deviation at 8. My X, and I need to set this for the larger value first. The larger value was 31. And so we're working with one battery, my sample size need to be 1, and this will be a less than. We're going to press calculate, and we get the probability that Z is 0.215, and we have to have our Z score. So the probability that Z is less than or equal to 0.125 minus, and we'll come back and do that in a second, but let's go ahead and write down this probability is 0.5497 minus, now I need to come back and work the other side because we just did the 31. Now I need to do the 25. So second vars, excuse me, stat test, Z test. And I'm just going to change that X to a 25. And by the way, we really are working with X right now. And I get a negative 0.625 minus the probability that Z is less than or equal to negative 0.625. And this is 0.2659. I'm going to leave a space there for the next part. Now, I need to have my calculator commands because we're going to run it as if we're doing a norm CDF. So my norm CDF, and by the way, I knew I was doing a norm, as I knew I'd use a norm CDF. It says because it asks for the probability. So anytime it asks for an app, so if it asks for an APP, if it asks for an area, if it asks for an area percent or probability, we're going to use a norm CDF. So this is a norm CDF. And here we go, second vars, norm CDF. The lower, oh, we need the lower bound. Well, the lower bound based on our graph is 25. Our upper bound based on our graph is 31. Our mean equals 30. And our standard deviation equals 8. All right, so here we go. Upper bound 31, mean 30, standard deviation 8. Plug all that in and we get 0.5. Wow, I have a problem. I need to go back. Oh, second vars, normal, CDF, lower bound, did not get in there. That's a 25. Sorry about that. So lower is 25, upper is 31, mean of 30, standard deviation of 8. And we get 0.2837. So this is my final answer. 0.2837. All right, let's subtract those two real quickly. 0.5497 minus 0.2659. All right, 0.2838. We're correct to 3 decimal places. We're in great shape. That's the answer. Please note, we have to have the points. You're going to have the probability statement. You're going to have the graph. You're going to have to show the plug-in to the Z. So you have to have both of these. You're going to have both of the Z scores, and you have to have the answer along with the calculator commands. The only thing you didn't have to have are these two values, but they may be helpful to you, but that's optional. All right, everything else that I have a check by is required. You might want to take a moment, write that down, make sure you have it, and then practice. All right, really good problem there. All right, and I can assure you there will be one very similar to this on the test. All right, suppose one customer who purchases the warranty is selected at random. What is the probability that the customer selected will require a replacement within 24 months? Ooh, once again, they ask for probability. If they're asking for probability, they're asking for an app. If they're asking for an app, it's going to be a norm CDF. So ultimately, we know at some point we're going to have to go to norm CDF. So they want to know what's the probability is going to require replacement within 24 months. So probability that it lasts less than or equal to 24 months. So I need to have a nice graph of this. So there's my probability statement, which is required. I have to have a graph. Well, our graph is still based on that mean of 30 months because that's what it's averaging. So here's our mean. But we want to know the probability X is 24 months. Well, remember, this goes to negative infinity. So we now have our probability statement and we have our graph. So these are two things. So next thing I need is my plug into my Z. So the probability that Z is less than or equal to and 24 minus 30 over our standard deviation of 8. So now we've plugged into that formula. That's great. So we're going to go ahead and run our stat test Z test. Stat test Z test. And mean is 30, standard deviation 8. X is now, instead of 25, is 24. And we have the probability that Z is less than or equal to, negative 0.75. So the probability that Z is less than or equal to negative 0.75, and it equals 0.2266. All right. So we have everything there except for our calculator commands. Well, remember, because they asked for probability, we're going to do norm CDF. So norm CDF, lower in this case, negative infinity, upper is going to be 24, mean is 8, standard deviation, mean is 30, sorry about that, and standard deviation is 8. Sometimes I start writing writing ahead of myself. So norm CDF, lower is negative infinity, upper is 24, mean is 30, standard deviation is 8. So we go and calculate that out just to verify that we have the right thing. Normal CDF, the second bars, normal CDF, lower bound, negative 9.99. That's your negative infinity. Our upper happens to be 24. Our mean is 30. Our standard deviation is 8. And we end up getting exactly what we have there. What do we have to have for grading? I have to have this. We have to have this. We have to have this. We have to have the Z calculation. That'll knock you down a half. We have to have this, and we need to have that as well. All right, so I'll leave that there for just a second while you copy it down. All right, so moving on to the next thing. In how many months from the date of purchase is it expected that 25%, and this is really important, because they said this time they are giving you the app. They give you the app. If they give you the app, then you have to use an inverse norm, right? If they ask for it, it's a norm CDF. If they give it to you, then it's an inverse norm. So we know we're going to be working with an inverse norm. So in how many months from the date of the purchase is it expected that 25% of the batteries will no longer work? Justify your response. All right. So once again, we're going to ultimately need our graph. And this is probably a good place to start with this one, is with the graph. So we have a mean of 30. And we had 25%, so we know we're less than halfway because the mean is at 50%, so this is going to be less than halfway. This area right here is 0.25, and we're going to be looking for this x. Not that I have to, but I'm going to write z equals x minus mu over sigma off to the side, and I'm going to start plugging in what I have. So what I have is 30. My standard deviation is 8, and we're looking for x, so we know we don't have that, and I need a z-score here. So how do I get the z-score? Well, I'm going to go in inverse norm. Let's go to the calculator. Second bars, inverse norm, so INV norm. The area, we know the area is 0.25, and we're looking for a z-score, and all z-scores have a mean of 0 and a standard deviation of 1. We end up getting negative 0.6744. All right, so negative 0.6744 equals x minus 30. I probably should rewrite that, so I'm going to just go ahead and rewrite it down here so it's a little bit neater for you. Negative 0.6744 equals x minus mu x minus 30 over 8. Now, at this point, I could solve by algebra, or I can plug back in and do a second inverse norm. All right, so I'm going to go ahead and solve by algebra. So times 8 plus the 30, and I end up getting x equals 24.604 months. Now, if I'd wanted to do an inverse norm, second vars, inverse norm, the great thing about that is it eliminates any error. And I can go, okay, the mean, 30, my standard deviation, 8. And I get the 24.6040 months. Now, things that I have to have. In order to receive full credit, I have to have this graph. I don't need to have that. Matter of fact, might even want to draw a line through it. I have to have my z-score. I have to have my plugin. I have to have my calculator command there where I show my inverse norm to get my z-score. I have to have that. And then I have to have this as well. Okay, hopefully that helps with this one. Apologize for, and you can have that right up there as opposed to here. It doesn't matter, but I do need to see it someplace, and we need to make sure we have that z-score. All right, next problem. The company has a gain of $50 for each customer who purchases a warranty but does not require a replacement. The company has a loss, a negative gain of $150 for who purchases a warranty. So if I purchase it and don't use it, the company makes $50. If they do use it, then the company loses $150. So what is the expected value of the gain for the company for each warranty purchase, right? So I'm going to pause this for just a moment and I'll come right back. All right, so what I was looking for is I had just written the slip out for when they lost money. Well, remember up in our up in the main prompt, they only had to replace it if it was within 24 months. And we had already calculated how many in part B that in 24 months they expected to have to replace it. All right. So we'd already done that work. And if you remembered that, you wouldn't have to go back and redo it. But I'm going to act as if we didn't remember it. All right. So basically 22% of the time we're going to have to replace it. The remainder of the time is a profit. So this is where they're going to lose money. The other way, they're going to gain money. But just in case we forgot that, part D, it says, so we have over here, we say, okay, how often do they lose money and how often do they gain? If we don't remember, I'm going to rework it. And I know that some of you may just speed through this part because it is a rework of what we've previously done. All right, so I need to figure out the probability that they lost money, but that's the probability that X is less than 24. And we know this is 30, 24 is less than 30. This area is a loss. They lose money. This area is a gain. All right, that's when they're going to gain money. Or this is their loss and this is their profit. So I need to figure out that the area of this first. So that's the probability that Z is greater, is less than or equal to 24 minus 30 over 8. Now we already have all this part above, but I'm still going to redo it just in case. So second vars, norm, stat, test, z-test. Oops. Stat, test, z-test. Press enter. 30, 8, 24. The 8 was our standard deviation. And we end up getting the probability that z is less than or equal to negative 0.75 equals 0.2266. All right. And our norm CDF for this, lower equals negative infinity, upper equals 24, mean equals 30, standard deviation equals 8. That doesn't look very good, but it's all there. Awesome. So I have all that information. I've shown my probability. So that's the probability I lose money. All right. So the probability of a loss equals 0.2266. The probability of a gain or profit equals 1 minus 0.266. 2266. So what is that? 1 minus 0.2266 equals 0.7734. And our expected value equals 0.2266 times how much in this case this is a loss, and it says, oh, if they use this, we're going to lose 150, so a negative 150 plus 0.7734 times our gain. All right, so let's see what happens there. We'll do that. 0.7734 times 50 minus 150 times 0.2266. So our expected value is we expect to make $4.68. Now remember, every single time that we do an expected value, we have to give what that means. So in the long run, the company expects to earn an average of $4.68 in profit on the warranties. They're not earning $4.68 on everyone. They're earning it on average. All right. So for this particular problem, the top part we did earlier. So if you remembered that, you didn't have to do that. So anything that was required would be below here. So you need to tell me where the loss is. You need to tell me where the profit is. Now, if you jump straight to this statement, that would be fine. I have to have this statement. It has to have this. It has to have this. It has to have this. And it has to have this. Not necessarily in the same order. Obviously, we're going to have that as well. And then we're going to need the sentence. In the long run, the company expects to earn an average of $4.68 in profit on the warranties. And once again, this very top part we did earlier. Okay, So that's D. Part E, in how many months from the date of purchase is it expected that 95% of the batteries will no longer work? Well, once again, this time they asked for an app. So if they asked for an app, we're working for an inverse norm. So we want expected that 95% of the batteries will no longer work. So here's my mean of 30. And this right here is 0.95. All right. And so we want to find this X value. As always, I start off and go Z equals X minus mu, and I plug in. And when I plug into that, just get this up just a little bit. There we go. We know we're looking for X, because that's what we have there, minus 30 over 8. So I need to calculate that Z-score. And once again, I didn't get myself enough room. And to do that, we're looking for an app. So that's going to be an inverse norm. So inverse norm. Like, and sorry about all that. Inverse norm. This is area equals 0.95. And we don't need to memorize all that. We can just go to the calculator, second bars, inverse norm, area. Okay. Mean. Well, we know it's 30 and we know our standard deviation is 8. So I end up getting a Z-score of 1.644. So Z equals 1.6448. I plug that in, 1.6448. Rewrite that, 1.6448 equals X minus 30 over 8. Now I can solve by algebra. Times 8 plus 30. And I end up, hey, you know what? X equals 43.1588 months. All right, and that's my answer. Now, I could have also gone back in there and go, you know what? I don't want to do that by hand. I want to do that by the inverse norm. So second quit, second vars, inverse norm, 0.95, use the 30 for the mean, the 8, and there's the 43.1588 months. Here's what I have to have. We have to have this graph. I have to have that. I have to have this, right? And then remember, I can have this one or this one. I don't have to have both, and I have to have this. All right? So that will take care of the part E. Part F, what percent of the batteries no longer work after 6 months? All right. What percent of the batteries no longer work after 36 months? Boy, it looked like my Zoom meeting had stopped. I was not very happy, but it's fine. So they're asking us for an area. And if they're asking us for an area, they're asking for an app. If they're asking for an app, it's going to be a norm CDF. So this right here is 30. Well, they say what will no longer work. So I'm looking for this huge area right here. And since they're asked for a percent, this is going to be a norm CDF. And we want the probability that X is less than or equal to 36 months, which is a probability that Z is less than or equal to 36 minus 30 over 8. So I'm going to do a stat test Z test. Stat test, z-test. 38, my x is 36. And I end up getting a 0.75. So the probability that z is less than or equal to 0.75 equals 0.7733. All right. Now, need to make the norm CDF. Norm CDF. Lower, negative infinity. Upper, 36, mean of 30, standard deviation equals 8. To receive credit or full credit, I have to have the graph. I have to have the probability statement. I have to have this. I must have the z-score. I must have the probability. I must have them. Okay, and that will take care of part F. All right. Finally, for this video, because we're going to break this into 2 videos, it says what percent of the batteries will work between 24 and 30 months. All right. What percent of the batteries will work between 24 and 30 months? So we want the probability that 24 is less than or equal to x, which is less than or equal to 30. And we need our picture. Well, remember in this case, our mean absolutely is 30, and we're looking for 24. So I'm looking for this area right there. And we're going to always go the larger value minus the smaller value. So the probability that z is less than or equal to 30 minus, excuse me, I said that wrong. Yeah, no, that's correct. Sorry. The probability that z is less than or equal to the larger value, which is 30, minus 30 over 8. Let's go ahead and plug that in. Now think about it. It's like, oh, we got 0. Oh, that means we have a z-score of 0. So this should be the second bars normal CDF lower bound negative infinity stat. I'm having trouble. Stat test z-test 38, and our x is 30. So this should end up being a z-score of 0, which is a probability of 0.5. And sure enough, it is. So the probability that z equals 0, which is 0.5. Now we have to do the other half, which is the probability that z is less than or equal to 24 minus 30 over 8, which we've already done a couple of times. So we go second stat test, z-test. And the only reason I go to stat test, z-test is because I really like getting my z-score calculated. Minus the probability that z is less than or equal to negative 0.75. And as we've gotten before, we found out that that was 0.2266. Now we need our norm CDF statement. And our norm CDF statement is norm CDF lower bound equals 24, upper bound is 30, mean is 30, and our standard deviation is 8. So second bars, norm CDF. Technically, I'm already done, but oops, 24. Upper bound 30, mean of 30, standard deviation of 8. And we get equals 0.2733. All right. So that's what I got from the norm CDF. If I check myself, 0.5 minus 0.2266, 0.2734, we're only off by tenths, hundred thousandths, tenths, hundredths, thousandths, 10,000, 1/10,000, not bad. All right, to receive credit, I need the probability statement. I need to have my graph. I need to have both of the plugins. I need to have both of my z-scores, and I need to have this probability right here. And I need to have the norm CDF statement. The only thing that's optional are these two, but I highly recommend writing them down. All right, this concludes the first video of the review. Hope it's helpful, and I will see you on the next one here shortly.